Question number 40 on the Review 2 worksheet. For the following question, show all your work, round your final answer to 2 decimal places if required, and write your final answer in complete sentences in the boxes provided. Okay, now class, I am not going to write the complete sentences. I'm going to let you do that, but I will say them, and then you can write them down after you try the problems, of course, on your own. Number 40, the flight of a football is modeled with the function h of t equals negative 16t squared plus 50t plus 2, where h of t is the height of the ball in feet. T is the time in seconds since the ball was kicked. 50 is the initial vertical velocity. We know that already. The b value is vertical velocity. And 2 is the initial height. That is the starting height. Our c value is the starting height. What is the height of the ball at 1.3 seconds? Well, 1.3 seconds, class, is just the value of t. So if we know the equation, we're going to plug in t, and it's going to tell us what the height is. That's what the equation of the flight of something does. We plug in the time and it tells us what the height is. So let's go ahead and write h of t, which is 1.3, is equal to negative 16 times 1.3 squared plus 50 times t, which is 1.3 plus 2. Let's put that in our calculator and see what we get. Hold on, let me get that in there. Alright, I gotta move this over so I can see it. This could be a little bit tough. There's no possible way I can see the equation with my calculator, so I will try my best to remember this. We've got negative 16 times 1.3 parentheses squared. Now I can see it, plus 50 parentheses 1.3 is our t value, close parentheses, plus 2. I'm going to press equal, and I got 39.96. So 39.96. By the way, that's going to be in our height measurement, which is feet. So in your sentence answer, you could just repeat the question. The height of the ball at 1.3 seconds is 39.96 feet. Remember, 2 decimal places. Or you could say the height of the ball at 1.3 seconds is about 39.96. Actually, no, let's see. That was exactly 39.96. You know what to say about. You can say is 39.96 feet. There's your sentence answer. Let's go to the next one, number 40. And if you don't write the sentence down, then I know you're not listening to the video. You're just copying it down, which really means you're not learning much. Most of the students who just copied the answers turned in the review sheets from the last test and still did badly on these questions because they wrote it all down, but they didn't understand why. That is how you get the answer. Take a look at number 41. A firework is launched, and the height is modeled with this equation. This equation, y equals negative 16 x times x plus 0.5 times x minus 4.5. I'm going to stop right here. That's intercept form, class. Let's hope they ask us for intercepts. Where y is the height in feet and x is the time since the ball is launched in seconds. If the firework does not explode, how long in seconds will it take to hit the ground? Yay. They're asking us for x-intercepts. When does it hit the x-axis? That would be hitting the ground. We've got intercept form. That makes this really, really easy. We're going to either find what is the x value that makes, this equation equal to 0, there's our first binomial, or makes this equal to 0. Now this one's going to be x equals negative 0.5. Well, that's negative time, so I'm going to say that one's out. This one's going to be if x minus 4.5 is 0, then x has to be positive 4.5. 4.5 minus 4.5 is 0. There is our number. And that is going to be time. We're looking for how long will it take? How long will it take? That's time. That's going to be in seconds. So your answer could be something like this. It will take the firework 4.5 seconds to hit the ground. Something like that. It will take the firework 4.5 seconds to hit the ground. Let's take a look at the next one. Loretta kicks a soccer ball from the ground. Hey class, if it's from the ground, we know it's starting off at height equals 0. The height of the ball in feet can be modeled with this function where t is time in seconds after the ball is kicked. How long will it take for the ball to hit the ground? And how long is time? So this is also an x-intercept question. Did I write that here? Yep. An x-intercept question. This is pretty simple. Let's divide this up. Either this term has to be 0, negative 16t equals 0, or t minus 2.3 equals 0. Well, this one's going to be t equals positive 2.3, because 2.3 minus 2.3 is 0. This one, negative 16 times what is 0? Well, that's always going to be 0. And think about that. That makes sense. The time 0, the ball's on the ground because Loretta is kicking it from the ground. But that one's not going to help us. They're not asking us how long does it take for it to start on the ground. That's actually at time 0. We want to know how long it takes for it to hit the ground again. That's going to be time equals 2.3. And again, our time is in seconds. So your answer could be something like this. It will take the ball 2.3 seconds to hit the ground. It will take the ball 2.3 seconds to hit the ground. All right, let's take a look at number 43. A water balloon is launched from a tower, and the height of the balloon in feet can be modeled with the equation. Okay, here's an equation, I got it, where x is the time in seconds since releasing the balloon. How long will it take for the balloon to land on the ground? Well, that's also an x-intercept, but our problem here is this equation is not in intercept form. We have to put it back in intercept form. And the way we do that is we're going to take these two monomials. Those can be combined together into a binomial. And the reason why is because this binomial here is a common factor. X minus 3.9. Now we have our equation in intercept form, and we can find out what will change. Here's our two solutions. Either negative 16x minus 4 equals 0, or x minus 3.9 equals 0. Well, this is going to be 3.9. That's probably our answer, but just for the heck of it, let's make sure this turns out to be a negative number. So negative 16x minus 4, we're going to move the 4 to the other side. That's going to mean negative 16x equals 4. We're going to divide both sides by negative 16. And let's draw an arrow here to get down to where our answer is. That means the negative 16 over negative 16 is 1, and x equals 4 over negative 16. If we simplify that, that's negative 1/4. And that's a negative value of time, which means it can't exist. So that one is out. And we end up with 3.9. And then we can put our unit of measure, which is seconds. So our answer should be the balloon will land on the ground in 3.9 seconds. We'll go ahead and start a new video to go to question number 44.